Myself, Professor P. A. Gaikwad, Assistant Professor, MPSC College, Panvel. I am discuss here today's topic of inorganic chemistry, that is coordination chemistry for SYBSC class. So, what is coordination chemistry? Coordination chemistry is the branch of chemistry which deals with study of coordination compound. In that coordination chemistry, the study of coordination compound is carried out, and therefore that branch is called as coordination chemistry. Then coordination compound. In that coordination compound, the complex ion or molecule involving coordination bond are called as coordination compound. So, in that coordination compound, the covalent bond is observed in between that metal ion and ligand, and therefore such a compound is also called as coordination compound. Then further, coordination compound are of two types, that is double salt and complex salt. When two or more stable compound combined together in stoichiometric amount and allowed to crystallize, the new compound is obtained. Such a compound is called as a molecular or addition compound. So what happens in that molecular or addition compound? Two or more stable salt combined together in stoichiometric amount, or we can say stoichiometric proportion, and these mixture are allowed to crystallize. So new compound is obtained. Such a compound is called as a molecular or addition compound. Then further, there are two types of molecular or addition compound. First is double salt, and second is complex salt. So what is about double salt? So those compound which lose their identity in solution. A molecular compound like potash alum is formed when potassium sulfate and aluminum sulfate are mixed in stoichiometric amount, and that solution is crystallized. So that compound is called as a potash alum. So that potash alum lose their identity in a solution, and therefore such a salt is called as a double salt. The example is K2SO4. K2SO4 is potassium sulfate plus Al2SO4 thrice. It is aluminum sulfate. So these potassium sulfate and aluminum sulfate is mixed in water, and that solution is allowed to crystallize, so it can obtain the new compound. Then another example is carnallite. So carnallite can be prepared by mixing saturated solution of potassium chloride and magnesium chloride followed by crystallization. That means here the solution of potassium chloride, that is KCl, and magnesium chloride, these solution of that salt is prepared in water, and that solution is further allowed to crystallize. It can produce new compound, and that compound is called as carnallite, that is KCl MgCl2 6H2O. Then these molecular compounds are stable only in crystalline state. So these carnallite is stable only in crystalline state, and when dissolved in water they lose their identity and break up into their constituent simple ions. For example, K plus, Al3 plus, and SO4 2 minus. Also K plus, Mg2 plus, and Cl minus ions are produced. So molecular compound which exist only in the crystalline state but lose their identity in solution by breaking up into their constituent simple ions are called as double salt. So double salt is nothing but it is a molecular compound which exist only in the crystalline state but lose their identity in solution by breaking up into their constituent simple ions are called as double salt. The properties of this salt are similar to those of their constituent ion. So in that molecular compound, the properties of this salt are similar to those of their constituent ion. Then second type of molecular compound is complex salt. So in this complex salt, it is a molecular compound which retain their identity by forming at least one complex ion in solution are called as complex salt. The properties of complex salt are different from those of their constituent simple ions. So example is FeCN2. It is a ferrous cyanide plus potassium cyanide, that is KCN. So it can produce FeCN2 4KCN, or we can say K4FeCN6. So it is a potassium ferrocyanide. So this potassium ferrocyanide is a molecular compound. A molecular compound potassium ferrocyanide is formed when ferrous cyanide and potassium cyanide are mixed in stoichiometric amount in solution, and solution is crystallized. So potassium ferrocyanide retain their identity even in solution. Thus, when potassium cyanide is dissolved in water, it forms potassium ions and a complex ion which exists a single unit, that is FeCN6 4-. Then the important terms which are involved in the coordination chemistry are studied here. So first term is about coordination compound. So what is coordination compound? So coordination compound is nothing but a coordination compound is a complex compound in which number of ions or molecules attached to the central atom or ions beyond the number possible on the basis of electrovalent bonding. Such a compound are called as coordination compound. So coordination bond are shown as M-L. So here M is a metal ion and L indicate ligand. For example, CuNH3 4. So it is a tetraamine copper 2 ion. So it is a example of a coordination compound. So in between that copper and NH3 ions there is a presence of coordinate bond, and therefore it is a example of coordination compound. Then it is a coordination compound in which the 4 ammonia molecules are coordinated to a copper 2+ ion. Nitrogen atom of each ammonia molecule donate its lone pair of electron to Cu ions. So here that Cu is act as a metal ion and 4NH3 is act as a ligand. So that NH3 have a tendency to donate lone pair of electron, and that lone pair of electron is accepted by copper ion. So coordination compound are of two types. First is a neutral coordination compound. Example is FeCO5, that is tetracarbonyl iron, or CONH3 tetraamine cobalt 3 ions. Then second type is ionic coordination compound. So in that ionic coordination compound which consists of ions in which at least one is a complex ion. So in that ionic coordination compound one is a complex ion is present, and therefore such a coordination compound is called as ionic coordination compound. For example, K4FeCN6. So here the ions FeCN6 is a complex ion and other ion potassium plus is a simple ion. Then another term is ligand. What is ligand? So here the molecule or ions which are coordinated to the metal atom or ion in a coordination compound are called as ligand. So in a coordination compound metal ions directly attach to a number of ions or molecules, and here the coordination compound is formed, and the number of ions or molecules which are attached to the central metal ion, that number of ions or molecules are called as ligand. For example, CONH3 6. So here 6NH3 is act as a ligand, and CO cobalt is act as a metal ion. So in this complex compound, 6 ammonia ligand are linked to CO3 plus as a central metal. Then ligand may be 3 different type, that is negative ions, positive ions, or neutral molecule. So negative ions, example of negative ions are Cn minus, that is cyanide minus, then NO2 minus, that is nitrite, then OH minus, hydroxyl ion, then NO3 minus, that is nitrate ion, then F minus is fluoride, Cl minus is chloride, Br minus is iodide. Then second type of that ligand is positive ions. There are 2 examples of positive ion. First one is NO plus, is called as nitrocilium, and second one is N2H5 is hydrogenium. And third type of ligand is neutral ligand. So example are CO, that is carbon monoxide, then NH3 ammonia, H2O is water, then NH2OH is hydroxylamine, and CH3NH2 is methylamine. So in this ligand there is no any charge, and therefore such a ligand is called as a neutral ligand. Then we see about IUPAC nomenclature. That means how coordination compound is named by using that IUPAC. So there is some rule, important rule. First rule is about while naming an ionic compound, the positive ion is listed first, followed by negative ion. So while naming an ionic compound, the positive ion is named first, followed by negative ion. So example is CONH36Cl3. Complex ion is the positive ion. It should be named first, and then the negative chloride ion is in K4 FeCN6. Potassium is to be named first, then complex ion.